All right, remember we had the big three log expansion rules. So we had the product sum rule where if we have multiplication inside of a logarithm, it can be expanded with addition of each individual factor. And if we have a quotient difference rule, well, remember that if we have a division inside of a logarithm, that the numerator over the denominator, we can expand that logarithm by making the log of the numerator minus the log of the denominator. And finally, the power factor rule states that if we have an exponent inside of the logarithm, that if we have log of a to the x, that this expands to become x log of a. In other words, log of log of the argument with the exponent, then the exponent can come out to the front as a factor. It's just these three rules. Now, instead of expanding it, we're going to be going from the expanded to the condensed. From the expanded to the condensed. From the expanded to the condensed. So let's get on with problem number 1. I warmed you guys up with numbers first. So condense the following logs. Okay, I've got the natural log of 6 plus the natural log of 2. Okay, so now that it's expanded, what do I need to do to condense it? Well, I've got an addition problem. Luckily, I've got the big three rules. Which one talks about log with the same base and it's an addition problem? Right, the product sum rule. So if it's addition with the same log base, in this case log base e, then I can combine them into one logarithm as a multiplication problem. So this is the product sum rule. ln of 6 plus ln of 2 can be combined into ln, I'm just showing my work over here, of 6 times 2 based on the product sum rule, or I guess the sum product rule, but I'm just going to keep it straightforward. We can condense it because of the product sum rule. Okay? Separate addition becomes together multiplication. And 6 times 2 is 12, so this just becomes the natural log of 12. And eventually we're going to get into variables. I just wanted to warm you guys up with numbers first. I smart, apparently I am. So the natural log of 6, close the parentheses, plus the natural log of 2. I don't really know what that is. However, let me check my work by doing the natural log of 12. Using the product sum rule, they're exactly identical. Okay? All right, number 2. ln of 6 minus ln of 2. Well, it's subtraction. Okay, I refer back to my big three rules. Which one talks about subtraction of separate log bases? Sorry, the same log bases, but what happens when I expand them with subtraction? I can put it together as a division problem inside of a logarithm. So log of a minus log of b tells me that the a is the numerator and the b is the denominator. So the positive goes on the top, the negative goes on the bottom. So therefore, ln of 6 minus ln of 2, well, the negative goes on the bottom, the positive goes on the top. So this becomes the natural log of 6 over 2 because of the quotient difference rule. So quote diff, and now I can put it together. The natural log of 6 minus 2 becomes the natural log of 6 over 2, or the natural log of 3. And just to check my work, I got my calculator right here. Clear, clear, clear. So I've got natural log of 6 minus natural log of 2. I have no idea what that is. Okay, that's apparently it's 1.0986, blah, 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 blah. But I'm going to compare that to the natural log of 3. Same exact decimal. The rules work. Okay, now I'm going to switch it on you a little bit. Okay, just to prove that we're flexible, the natural log of 2 minus the natural log of 6. What do you think is the difference between problem number 2 and problem number 3? This time, it's natural log of 2 minus the natural log of 6. In this case, the 6 goes in the denominator and the 2 goes in the numerator. So this becomes the natural log of 2, 6, because, yet again, this is the quotient difference rule. All right. And can I simplify 2/6? Yeah, if 6 over 2 is 3 over 1, then 2 over 6 is 1/3. So this just becomes the natural log of 1/3, whatever that is. And just to check my work, I can go, this time the natural log of 2 minus the natural log of 6. I have no idea what that is. Apparently it's negative 1.0986, blah, 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 blah. But then I'm going to check my work by doing the natural log of 1/3. Love it. It's the exact same decimal because of the quotient difference rule. Okay, now the 2 times the natural log of 6. 2 ln of 6. Okay, what happens if I have multiplication in front of the logarithm? Okay, let me go back to my rules. If there's multiplication in front of the logarithm, that meant that the factor out in front can go inside as the exponent of the logarithm. So since we've got 2 multiplied by the natural log of 6, I'm going to leave the natural log of 6 alone. However, I'm going to pull this 2 inside of the logarithm, so that becomes, make that little green mark right there. You don't have to mark that. I'm just showing you that I'm going to take this 2, I'm going to put it inside the logarithm, so 2 natural log of 6 becomes the natural log of 6 squared because of the power factor rule. The factor becomes the power in this case. And just to simplify this, 6 squared is 36. So this is the natural log of 36. Okay, and just to check my work, I have no idea what 2 natural log of 6 is. Apparently, it's 3.58351, blah, 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 blah. But I'm going to check my work by doing the natural log of 36. All I care about is, are the decimals the exact same? They are exactly the same. The power factor rule is in our favor. Okay. Now, just to make sure that we're flexible, number 5. This time, it is 6 ln of 2. So the factor in front is 6. So that's going to go inside of the logarithm as an exponent. So this now becomes the natural log of 2. But that exponent is going to go inside as an that factor goes inside as an exponent. So this instead is the natural log of 2 to the 6th because of, yet again, the power factor rule. Okay, I'm just going to do this in my head. Okay, 2, 4, 8, 16, 32, 64. So the natural log of 2 to the 6, 2 to the 6 is 64, Nintendo 64. Okay, and just to check my work, because I'm always very, very cautious, let's just say I have no idea what 6 times the natural log of 2 is. Because the truth is, I don't. Oh, not 22, I want just 2. I have no idea what 6 natural log of 2 is. Apparently it's 4.158883083, blah, 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 blah. But let me check the natural log of 64. Is it going to be 4.158883083, blah, 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 blah? It is. I just freestyled a new song for you. You're welcome. But yeah, the power factor rule reigns supreme. But just to let you guys know, we did this to warm up. Now we're going to put some variables in there. Okay. Oh, sorry. Before we do that, I wanted to challenge you guys and see what can I condense log of 9 plus 3 log of 2 minus 3 into. And then we're going to check our work. Okay. Well, usually the power factor rule is the last rule when we expand. This time, I want to clean this part up. So I've got log of 9 plus 3 log of 2 minus log of 3. So my philosophy with this is, okay, I'm going to clean this part up. That is screaming to me the power factor rule. So this becomes log of 9 plus, well, this becomes 3 log of 2, or log of 2 to the third. Minus log of 3. So log of 9 plus log of 2 to the third minus log of 3. Okay, cool, cool, cool. So now this becomes log of 9 plus log of 8 minus log of 3. Okay. So now, remember, I could do this in 2 steps. I could do, hey, this is product sum, and this is quotient difference. But I like my idea of positives go on top, negatives go on the bottom. So let me just make this one neat little logarithm right here. Positive 9, positive 8, negative 3. So 9 times 8 goes on the top, and 3 goes on the bottom. You can simplify from here, okay? Some people know how to cross cancel and cancel out the 9 and the 3. I'm going to do it the long way just to make sure everybody's cool. 9 times 8 is 72 divided by 3. So log of 72 thirds, that's no different than log of 24, the end. Okay, so just to check my work, I have no idea what log of 24 is. I have no clue. Apparently it's 1.3802, blah, 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 blah. But I'm going to check my work by applying log of 9 plus 3 log of 2 minus log of 3. Log expansion, please be correct. Look at that. Ah, I love log expansions and log condensing. You can just check your work by plugging in the exact same values, and you'll get the same decimal. Challenge yourself and see if you can do number 7. 3 log of 3 plus log of 4 minus log of 12. Okay. All right. Now that you've paused it and done it on your own, hopefully, let's see what we can do. 3 log of 3. Well, if I have a factor outside, that becomes an exponent inside. So that becomes log of 3 to the third plus log of 4 minus log of 12. And the reason why I did what I did from here is because of the power factor rule. Now I'm going to simplify 3 to the third. That would be 27. Log of 27 plus log of 4 minus log of 12. Okay. Positives on top, negatives on the bottom. Let's do this. So that becomes log of positives on top. That's 27 times 4. And negative 12, the negative is the 12, so that goes on the bottom. And now, let's see if we can simplify this. So that becomes log of 27 times 4. I could do that in my head. If 25 times 4 is 100, then 26 would be 104, 27 would be 108. So 108 divided by 12, whatever that is, I'm going to get my calculator. 108 divided by 12 is 9. So this whole thing could have been just simply the log of 9. And just to check our work, I don't know what log of 9 is, but you know what? I got a calculator. Log of 9 is 0.95424, blah, 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 blah. Let me do 3 log of 3 plus log of 4 minus log of 12. Same exact decimal. Expanding it out versus condensing it all in. All right, now let's do some variables. Okay. All right, log of A minus log of D. Just to warm up with the variables, what should I be doing? Okay, so this is log of A minus log of D. Subtraction with the same log base means it's a division problem. So this becomes log of A, the numerator, over D, the denominator. And why is it that we did what we did? Quotient difference rule. I find it easy to cite the source. You don't have to. I find it much easier to have it stick in my brain. Quotient difference is the reason why this works. Number 9, the natural log of U plus the natural log of W. Condense that into one neat little logarithm. Addition with the same log base means it could be together with the same log base as a multiplication problem. So that'd be the natural log of UW, or U times W, and that is the product sum rule. All right, now we're cooking. Okay. 2 log of x plus 9 log of y. Okay. If it's a factor out in front, it can go inside as the exponent. If it's a factor out in front, it can go inside as an exponent. So this becomes log of x, and that exponent is going to fly to the front. That's going to be log of x squared. Plus 9 log of y, well, that 9 can go inside the logarithm y to the 9th power. And the reason why is because of the power factor rule. Pow, fact. Is this one neat little logarithm yet? Not quite. So what do you think I need to do to condense this into one neat little logarithm? Well, it's an addition problem. So addition expanded becomes multiplication inside of the logarithm. So I can make this neat by saying log of x squared plus log of y to the 9th is actually log of x squared times y to the 9th power, and that is because of the product sum rule. The end. It's all one neat little logarithm right now. Love it. All right, number 11. 6 times the natural log of p minus 4 times the natural log of q. So 6 ln of p minus 4 ln of q. On the first step, what do you think I should do? I'm going to get the factor out. I'm going to get the factor from the outside and put it as an exponent on the inside. Factor from the outside becomes the exponent on the inside. So now this becomes the natural log of p to the 6 minus the natural log of q to the 4th. The reason why this works is because of the pow fact rule, power factor. Now, how do I get this to be one neat little logarithm? Well, if it's subtraction expanded, that means it's division inside. So I'm going to convert this into the natural log numerator minus denominator. So that'd be p to the 6 on top and q to the 4th on the bottom. So the natural log of p to the 6 over q to the 4th can be expanded into 6 ln of p minus 4 ln of q. Nicely done. And that reason why is because of the quotient difference rule. Okay, moving on. Next page. How many problems we got? We're going to go up to 15. Okay. 5 log of... Ooh, this is a tough one. 5 log of x plus 7 log of y minus 4 log of z. What's my first move? To condense this into one neat little logarithm. Okay, so now that I've got 5 log of x plus 7 log of y minus 4 log of z, I can make the factors out in front become exponents inside. So now I've got log of x to the 5th plus log of y to the 7th minus log of z to the 4th. Come on, ink. So let me just read it so that nobody's confused. Log of x to the 5th plus log of y to the 7th minus log of z to the 4th. Okay, now what's my big hint? If you're ever confused about which goes where, positives go in the numerator, negatives go in the denominator. So I can make this one neat little logarithm by saying log of, okay, x to the 5th. Is that positive or negative in front? Well, that's positive, so that goes on the top, x to the 5th, plus log of y to the 7th. Okay, that's positive, so y to the 7th goes on the top. Minus log of z to the 4th, so the z to the 4th is in the denominator. So that is how you completely simplify, how to completely condense a logarithm when it's fully expanded and all wild like that. All right, just to give you another chance, 6 natural log of w plus 3 natural log of t minus 15 natural log of r. Okay, first things first, I can make the factors go inside as exponents. So natural log of w to the 6th plus natural log of t cubed minus natural log of r to the 15th. Okay. Positives on top, negatives on the bottom. So now I can make this whole thing the natural log of top over bottom. W to the 6th is on team positive. T to the 3rd is on team positive as well, so they both go on the numerator. And R to the 15th is on team negative, so that goes in the denominator. There you go. All right, here we go. What do you notice about problem number 14 that we haven't seen yet? Yeah, there's 2 negatives. Okay, well, let's just use my big hint. Positives on the top, negatives on the bottom. So we've got 8 log of n. I'm going to make that 8 go inside as an exponent. So this becomes log of n to the 8th, okay, minus. That 12 can go inside as a logarithm, so that becomes minus log of v to the 12th minus 3 log of y, so that 3 can go inside as an exponent, so that becomes minus log of y cubed. All right, now, what's my big tip? You can use quotient difference. I don't want anybody getting confused, though. Positives on top, negatives in the denominator. So that becomes the log, okay, n to the 8th, you go on top. V to the 12th, you're negative, so you go on the bottom. y to the third, you're negative, so you go on the bottom as well. The end. One last problem to go, and then it'll be the end of the video. All right. Ooh, ginormous. Take a deep breath. Natural log of c plus 5 natural log of b minus 4 natural log of g minus 28 natural log of a. Okay. So there's no factor out in front, so I suppose I could just, no harm, no foul. I could rewrite this as the natural log of c. There is a factor out in front, so that becomes the factor can become an exponent in the inside. So that becomes 5 natural log of b can become natural log of b to the 5th. Okay. Subtraction. That could go in the denominator, but for now, negative 4 natural log of g, so that can become negative ln of g to the 4th. All right, minus 28 ln of a. Okay, well, that can become minus the natural log of a to the 28th. Okay, positives on top, negatives in the denominator. So positives in the numerator. All right, I see a c. I see a b to the 5th. G to the 4th, you go on the bottom. And a to the 28th, you go on the bottom. And that is how you condense a logarithm. Okay. So today is Friday. So on Monday, we're going to have a big review day, and then we're going to have a test. The test will literally be on expanding and condensing logarithms. That's it. After that, we're going to have one final log test on word problems. So why do we need to know about logarithms and exponential functions in word problems? So Monday will be a big review day, and then Tuesday will be the test. All right, see you guys Monday.